Assalamualaikum and hi everyone. So today we are going to go through topic 1, which is Introduction to Programming. In this topic, we are going to look into the computer organization, which is the hardware and software, programming languages, compilers and interpreters, and also the programming process and different types of errors. The learning objectives of these topics are to explain the computer organization, to explain the hardware and software components of the computer, the evolution of programming language, and also to understand the process from source code to running the program, and also all the main steps involved in programming tasks and the errors that can occur. So, what is programming? Computer programming is the art and science of designing and writing computer programs, while computer program is the sequences of instructions written in a programming language to achieve a task or to solve a problem. Basically, before you write the code, you have to think about the steps or design that your code has to follow to solve a problem. That means you don't simply write the code straight away. You need to plan on what are the steps, which can be done by writing step 1, step 2, and so on. Can you give me examples of programming languages that you know or have heard of? For example, Java, which is what we are going to learn in this course. There are also other programming languages such as C programming, C++, Python, and many more. What about HTML? Is it a programming language? HTML is a markup language, not a programming language, because it does not have programming logic. What about JavaScript? Is it a programming language? JavaScript is a programming language, more commonly called as the scripting language. It is similar to Java, but JavaScript code does not need to be compiled like Java. Let's look at this example. So this code is taken from w3school.com. In this code, we have H2, which is the heading, P for paragraph, and then IMG for image. So HTML gives structure and style to web pages. What does JavaScript do to this code? So if you look at button on click, that is an example of the JavaScript, where JavaScript gives web pages interactive element that engage a user. In this example, if the user click on the button that says turn on the light, then the light will be turned on to this yellow. If the user click on turn off the light, then the bulb over here will change the color. In the Java code, it basically switches from one image to another image depending on which button that the user click, which is either turn on or turn off the light. The arrow that is pointed on the code is showing that if the user click on turn on the light, the picture that will be called is the pic_bulbon.gif. If the user click on turn off the light, then the image that it will call is pic_bulboff.gif. So basically, we have two images, one with the bulb on and another one is the bulb off. So when the user click on the buttons, it seems like there's some animation going on, even though we only use two different images. Now let's look at different programming languages. So this slide is showing an example of Java code. It is then compiled on the terminal using javac, which produced the bytecode named example_java.class. To run it, we would write Java and the name of the file, which is example_java. The output that will appear is the sentence that we have written in the code, which is this is Java. Don't worry if this doesn't make much sense now. We haven't learned how to write the Java code yet. This is just to show you an example of how a Java code would look like. A simple example of C programming language code is shown here. The code is doing similar to what we have written in our Java code. The main difference between any programming languages is in the way the code is being called and written. The concepts are very similar. So if you have learned and know one programming language, pretty much you can learn other programming languages easily. In this C code, to compile it, in the terminal we would write gcc, which is calling the compiler to compile example-c, and the output file is called example-c. -o is used to specify the output file name. If we do not use this option, then an output file with the name a.out is generated. After compilation, executable is generated and we run the generated file. To run it, we can write ./example-c, which is the output file produced after compiling. It will give us the output. This is C programming. This slide shows C++ code. Previously, we have used the keyword print to display the output on screen. In C++, we can use cout, which is the standard output stream shown in line number 4. It can be seen on this line that the way of writing C++, C, and Java is slightly different, even though it does similar thing, which is to display a sentence when we run the code. To compile C++, in the terminal we will use G++ and running it by using / and calling the output file, which in this example we name it as example C++. The output that we get is, it displays this is C++. Another example of programming language is Python. Python has simpler programming syntax, which is the way of writing it, as can be seen here. Only one line is needed to display similar sentence as in other examples of Java, C, and C++. To run the code, we can write Python and the name of the file. It will compile and execute it straight away. We do not need to compile it separately, unlike other programming languages. Introduction to computer. So what is a computer? A computer is an electronic device that stores and processes data. Computers have greatly affected our daily life and helping us to complete many tasks. Computers have been around for quite some time now, and we can see how computers have evolved in terms of the sizes, specifications, capacity, processors, and also in terms of the prices. A computer requires both hardware and software. So hardware is the physical and tangible parts of a computer. It can be the keyboard, monitor, disk, wires, chip, and so on. The software part is the invisible instructions that control the hardware and make it to perform specific tasks. Software is the programs and data, and the program is a series of instructions. So why does a computer requires both hardware and software? So a computer will take in data, which is the input, for example, maybe through the keyboard, and then process the data using any software, any OS, or for example, it might use Microsoft Word, and then output the information through monitor, which means that it displays the output. Some of the main hardware part of a computer includes CPU, which stands for Central Processing Unit. It is situated on the motherboard. We have main memory or RAM. RAM stands for Random Access Memory. And then we also have secondary storage, for example, the hard disk drive HDD and also solid state drive SSD. We also have the I/O device, which is the input or output devices. For example, the keyboard and mouse are input devices, and the monitor that displays anything that we type is the output device. For the software part of a computer, it can be separated into two categories, which are system software, for example, the OS, operating system, and application programs or application software, that is any other generic programs such as Microsoft Word, Excel, and so on. This figure shows how all of the components are related to one another. For example, when we turn on our computer, the operating system OS is loaded into the RAM. RAM is the temporary memory and is directly connected to the CPU. CPU will execute the commands and instructions, and then display the graphical interface that we see onto the output device, which is the monitor or the screen. Let's look at another example. Say that we want to use a word processing program. When we open the program, it will be loaded onto the RAM. CPU executes it and displays the program on our screen. If we want to open a file that we have previously saved, it will read from our storage device, which is our hard disk, pen drive, or USB drive. It will process it on the CPU and display the content of the file on the screen. Information is also moved between RAM and secondary storage as needed. If we type something on our keyboard, which is the input device, CPU will process it and display it on screen. This happens quickly. Communication devices here can be the modem and router to allow us to get connected to the internet. It can also be any external Wi-Fi or Bluetooth adapter or dongle. Those are just different names to refer to the same communication device. This figure shows the hardware components of a computer. This is an older computer, so it has the slot for floppy disk. It is also shown the classic size of the monitor, where now we have thinner monitor. There is also the CD-ROM, where ROM stands for read-only memory slot, where typically newer computers and laptops do not have CD, DVD, or Blu-ray drive because most software can be downloaded, so these drives are redundant. However, we can get this drive externally, where the external CD, DVD, or Blu-ray drive is connected using the USB. Also, in this figure, it shows a modem. So what is a modem? Is it the same as a router? In simple words, a modem allows us to connect to the internet. A router connects devices to Wi-Fi. See if you can see modem and router at your home. Usually, a modem and router are two separate devices. However, there is also modem-router combo where everything is within one device. Now let's look at CPU. CPU is a brain of a computer. It is on a chip called a microprocessor. Examples of well-known microprocessor brands include Intel, AMD, and Ryzen, where there are many varieties such as Intel Pentium, Intel Core i5, and Intel Core i7. CPU continuously follows the fetch, decode, and execute cycle. As we have seen before, the instructions are retrieved from the main memory, which is the RAM, that is a temporary memory and it is directly connected to the CPU. It then determines what the instruction is, and in the execute part, it will carry out the instruction. The CPU contains arithmetic or logic unit, which performs calculations and makes decisions. There's also the control unit, which coordinates the processing steps, and there are also registers, which are the small storage areas. Random access memory, RAM, is a repository for both program instructions and data manipulated by a program during execution. It is also known as the main memory. RAM is volatile, meaning that the start information is lost if the electric power is removed. So basically, the characteristics of a RAM is volatile, it is fast and works directly with the CPU, but it has low capacity and RAM can be expensive. Storage device that provides permanent storage for information is also known as the secondary storage. Unlike the primary memory, or RAM, or the main memory, the secondary storage is non-volatile, meaning that the information will still be there even after you have switched off the computer. It has larger capacity, which can be in terabytes and can be purchased at a reasonably cheap price. Secondary storage, it is not directly connected to the processor. Examples of disk drive include hard disk drive, HDD, we have solid state drive, SSD, and also hybrid solid state drive, SSHD. So what is the main difference of HDD and SSD? So HDD uses mechanical platters and a moving read or write head to access the data. SSD is a faster type of device that stores data on instantly accessible memory chips. SSD doesn't have any moving parts, meaning that it can withstand accidental drops better than HDD. In this figure over here, you can see HDD. For CD drive, we have CDR, where R stands for recordable. We have CD-RW, RW stands for rewritable, and there's also DVD, which is digital optical disc. We also have Blu-ray, which supersedes the DVD format. All these formats are still available. If you plan on getting an external CD, DVD, or Blu-ray drive or player, you should check the formats that they support because not all devices or players support CD, DVD, and Blu-ray. Input device allow communication between the user and the CPU. It is used to enter data, program, and commands in the CPU. This slide shows examples of input devices such as the keyboard, mouse, microphone, and also the scanner. Output devices also allow communication between the user and the CPU. It is used to display or print information. This slide shows examples of output devices such as the monitor, printer, and projector to display the processed information. Speakers and headphones are also examples of output devices. A communication device connects the computer to the internet. For example, we have the modem, which is a device that converts analog signals to digital and digital signals to analog. And we also have network interface card, which connects a computer to a LAN. This figure shows an example of how a motherboard looks like. Newer motherboard looks slightly different but roughly would have similar hardware as this. In this figure, we can see that a motherboard contains the processor chip, memory chip, there's also the memory slots, expansion slots for adapter cards, and also different types of adapter cards. I have mentioned in previous slides that software can be categorized into two, which is the system software and also the application software. So in the system software, it keeps all the hardware and software running together smoothly. An example of it is the operating system, or OS. The OS controls all machine activities and provides the user interface to the computer. It also manages the resources such as the CPU, the memory, and also the input and output. Example of known OS would be the Windows, Unix, Linux, and also the Mac OS. Application software is the generic term for any other kind of software. For example, we have word processors, spreadsheets, web browsers, and any other applications such as games. To summarize, so far we have covered the computer organization where we have looked at the hardware and software part of a computer. In the next part, we will look into programming languages, compilers and interpreters, and also the programming processes and different types of errors.